Alright, here we go. So we're going to do our solutions for the concept questions 1 on density. So problem number 1, if one material has a higher density than another, must the molecules of the first be heavier than those of the second? So we're asking if high density, so we're going to start for AP with high density means particles are very close together. Particles, atoms, molecules, however you want to say this, are very close to one another. There are few empty spaces in a high density material. So the weight has no relationship to density. So what we're saying is something with high density has a lot of particles in the same space. Weight is a measure of gravitational force. And it depends on mass. On mass and gravity. So the confusion that this question is hitting at is that density and weight are not the same thing. Density is a measure of how close the particles are, and yes, an object with high density will also have a lot of particles in a small space. But just because you have a lot of particles does not mean they weigh a lot. For example, if I was taking a whole bunch of air particles and I compressed them into a very small cylinder, that does not make the weight of the air particles change. The weight of the air particles, each particle has some weight due to gravity, and having more of them means I have more mass, therefore I have more weight. That does not mean that a higher density material, the particles themselves will weigh more. So be aware of that. So like an atom of nitrogen and an atom of air, or not air, an atom of iron have different weights because they have different numbers of protons, neutrons, and electrons. Doesn't matter how close or how far apart you put them. Each one is dependent on its own internal structure. Okay. Ice cube floats in a glass of water to the brim. What can you say about the density of the ice? The density of the ice must be less than that of water since it is floating. So for something to float, that means it has less density than the material or the fluid that it is put inside. Why don't ships of iron sink? Whoops, number 3 first. An ice cube floats in a glass of water filled to the brim. As the ice melts, will the water overflow? The answer here is no. When the ice melts, it will turn into water. So, the ice will fill that same space as it did before. So it's not about, so in this case, when you have a cube of ice, the cube of ice turns into liquid water when it melts. Ice is less dense than water, which means that ice will take up less space than the same volume of water. In this case, we have an ice cube, some of it's inside and some of it's outside, and what you need to keep in mind is that when that ice melts, normally if we had equal volumes of ice and water, the ice would have fewer particles, which means it wouldn't be able to fill up the hole for the water. But since we have an ice cube that's floating inside of it, all of it will melt, and it will fill up the exact same space that the ice cube originally used. And so, because the ice is less dense, when you melt it, the particles will get closer together. When the particles get closer together, it fills up a smaller volume, and so the level of the ice will just match the level of the water that was there or is there now. You can do this at your house if you're not sure. It's a good experiment to do in your house, actually. Okay, number 4, why do iron ships mate? We incorporate air spaces inside the hull. So that the overall density of the ship is less than that of water, or salt water, depending on if your ship is in the ocean or if your ship is in a lake. Okay, number 5. And this will probably be the last one I fit on this page. It says a large plate of glass is dropped and breaks into 2 smaller pieces with one piece larger than the other. Rank in order from largest to smallest the densities of the whole plate, the large chunk, and the small chunk. Indicate ties if necessary. Well, the material just broke in half. It didn't change the material it is. So even though you have different sized chunks, proportionally they will have the same volume and mass ratio as they did before, because the glass is still glass. It's broken glass, but the material property, density, does not change because it's still glass. So my answer here would be whole plate has the same density as large chunk, which also has the same density as the small chunk. So all of them have the same density because they are the same measure. They are the same material, sorry. Okay, question number 6. We are still continuing on density concept questions 1. So number 6, a fish sinks or floats by changing the amount of air held in its swim bladder. Explain how this change in air amount affects the overall density of the fish. If the fish takes in air to its swim bladder, the overall density will decrease because air has a very small density. So in a sense, we are now ratioing the fish's density with the air's density, and we're making the overall density of the fish go down because we've got more air than we had a minute ago, so we have averaged a lot of small numbers into our problem. Okay? So, but if I was to go the other way, so if the fish releases air, then the mass of the fish will go down a small amount, but the volume of the fish will decreases more. So mass over volume, if you make the denominator get even smaller, then the overall density will go up. So as we take air out, now we're getting closer to the true density of just the fish, and just the fish will have a larger density than the density of water. So the game here is you're trying to add air to get your overall density to be less than water's, or you take in water or fluid, or you get rid of air to make your overall density go up so that it would be larger than water. Okay. Why does cream rise to the top? The scientific answer here is cream rises to the top of milk because it is less dense than whole milk. So there's your physics reason for why cream rises to the top.